Welcome everyone to the video lecture. My name is VIMALRAJ, and in this video we are going to see about the cutting tool properties. And before going into our topic, we first we see on which basis the cutting tool material is selected. But first we will see what kind of work material we are going to machine, and then at which rate we are going to machine or power available for the machine, and then we see the properties of the cutting tool material, and we will compare it with the work material, and choose a best material for our cutting tool. In this video we are going to see about the properties of the cutting tool, and the first property we are going to see about was hardness. Hardness is the resistance to the localized deformations, cutting, abrasions, and or scratching. For a cutting tool material, the hardness must be higher than that of the work material, and that is machining, because when we do machining, machining, and the cutting tool material doesn't undergo deformation, scratching, cutting, or abrasions to do its contact with the work material. When the hardness of the cutting tool material is higher, uh, the it will not undergo such things, and it will remain same, and it will also increases the tool life. And next property we are going to see about was hardness. As we see previously, hardness is the resistant to deformation and etc. Hardness is the ability to withstand that hardness at the higher temperature or elevated temperature. When we are doing machining, and the temperature of increases due to the interaction between the tool material and the work material. When the temperature increases, the tool must not deform when it deform from its original shape. uh, to which the hardness must be higher, so that it cannot deform, and the hardness of the material will be higher at the elevated temperature. As we see in the picture, two tools are used. The two tools, when we machine, the two tools remain undeformed at the higher temperatures. And the next property we are going to see about was wear resistance. Wear resistant is the resistant to the wear due to the adhesion or abrasion between the two materials. Generally, when we make two materials in contact, there is some adhesion and abrasion between them. As like it, this and there is an adhesion and abrasion between the uh, tool material and the work material when we do machining. And the zone the in the picture, the zone red zone indicates the adhesion and abrasion, and the and where the wear will happen. When the wear resistance of the material is higher, the wear due to the adhesion and abrasion is prevented, and the tool life is improved. And then the next property is, we are going to see about was toughness. Basically, the toughness is the resistance to fracture, and its quality, the quality said, we said that its quality depends upon the amount of energy, that is maximum energy it can be absorbed, maximum energy that can be absorbed before fracturing. Okay, then when the for the cutting tool material, the toughness must be higher, so that it can withstand the load at the beginning. When we do machining, there is an initial load, initial and sudden load when we make contact, make contact between the tool and the work material. The load must be withstood without the breaking of the tool. And there is an force fluctuation due to the imperfection in the work material. We do not assure that work material is proper, smooth, and it is without up and downs, and there is it is in a proper manner. We machining the material for to be to get it to get it be in a proper manner. So when we do machining, to do the imperfection, there is a force fluctuation, to do which the tool may break. To uh, to withstand this, the toughness must be higher, so that the rule may not break. And the next property we are going to see about was coefficient of friction. The tool must have low friction, low coefficient of friction. Low coefficient of friction is a ratio of the frictional force resisting the motion of the two surfaces in contact to the normal force pressing the two surfaces together. And there is a coefficient of friction between the tool and the chip. Chip is not nothing but the removed part of the work material by the tool, and there is a coefficient of friction between them, chip and the tool, and it should be low, so that it could allow for a lower wear rates and better chip flow. And the next property we are going to see about the thermal conductivity. Thermal conductivity is the rate at which the heat is transferred by the conduction mode of, which is the conduction, which is the one mode of heat transfer. And um, uh, and and then uh, for a cutting tool material, the as we seen earlier, there is a generation of heat in it. The generated heat must be dissipated to the outer surface fastly, um, and then uh, it, dissipation of heat fastly will prevent the tool, and it give you a good lifetime. So the material must have the higher thermal conductivity. And this is the graph between the hardness and the toughness. In this, we can see the diamond have the highest hardness, and high carbon steel have the lowest hardness, but have the highest toughness. But diamond have lowest toughness than this, and we can see that the material the highest hardness will have lowest toughness, and with the highest toughness will have the lowest hardness. And the next we are going to see about the graph between hardness and the temperature. It will tell about the thermal conductivity and hardness also. As we see in the graph, the high carbon steel, uh, in the high carbon steel, the hardness will then dramatically decreases when the temperature increases, and so that we can conclude that it have the low hot hardness. Hot hardness is nothing but the ability to withstand hardness at higher temperatures. When the and it is also uh, it is also seen that in high carbon steel the um, conduction is thermal conductivity is low, so that the temperature is remain in the tool, which tends to decrease in the hardness. And the ceramic of the uh, hardness range. And this next graph shows the wear resistance of different materials. And from this graph we can know the wear resistant ranges of different materials as shown in the graph, and then in this graph shows the coefficient of friction of three different materials at two different velocities at which we are doing machining. By seeing these properties, we can come to a conclusion that the all properties will not present in the one material. uh, yeah, a material can have some properties we see. We must have choose the material the in which the property that we want will the we want will is present, and it will be decided by seeing the what kind of work material we are machining, uh, and compare the properties of the tool materials, and that of the work material. We can come to an conclusion that this material is suitable for the tool we are using. Yeah, this is the reference where the topics are taken, and thank you.